Hi, I'm Anna Lello-Smith, and today I'm going to be talking about how forest fires impact regenerating tropical forest, and specifically how they affect their ability to support biodiversity. So, as the conference theme suggests, forest restoration has become a really important piece of global efforts to mitigate climate change, to improve human livelihoods, and conserve biodiversity. And restoration is especially needed to protect biodiversity within tropical forests that continue to experience high deforestation rates. Restoration can encompass many different strategies, from unassisted or assisted natural regeneration to various active reforestation techniques. And maybe surprisingly, natural regeneration can actually be at least as effective as active planting for recovering biodiversity, and also tends to be cheaper and more scalable across large areas. So I'm going to be focusing this talk on natural regeneration, where forest is allowed to grow back on its own on reclaimed agricultural land. So a big challenge is that a lot of priority areas for forest restoration are working landscapes, meaning that people are living and working there, and so human activities may complicate the potential for naturally regenerating lands to support biodiversity. And one of those complicating factors in working landscapes is fire. So fire was not historically part of the natural disturbance regime of humid tropical forests, but it's becoming increasingly frequent and severe with agricultural expansion and regional drying due to climate change. But even though fire is emerging as a major force in these same landscapes where restoration is being planned and implemented, we still don't know how fires affect the value of regenerating forest for biodiversity. And it might seem obvious that fire is bad for regenerating forest and biodiversity, but it's actually not that simple. And we do have some information about how fires affect biodiversity in mature tropical forest. So in mature forest, repeated burning has been shown to drive out forest interior species, but it actually favors species characteristic of secondary forest. And so that begs the question of how burning will impact biodiversity in forests that are already secondary, so regenerating. And one option is that forest interior species are too sensitive to use regenerating forest, and the species that do use regenerating forest are resilient to fire. But because regenerating forests often have simpler vegetation structure and drier microclimatic conditions than mature forest, it's also possible that species that use regenerating forest may be especially vulnerable to fire. So we asked how repeated burning of regenerating cattle pastures impacts their use by forest bird species. And we chose to focus on forest-dependent species instead of the habitat generalists that often colonize early successional habitats, because we wanted to look at how burning impacts the species that are most in need of forest restoration. And we did this in a landscape of naturally regenerating cattle pastures in the Maya Biosphere Reserve in northern Guatemala. So this reserve protects a huge area of mature forest, the largest north of the Amazon, but it's still experiencing really high rates of deforestation, at 90% of which is driven by illegal cattle ranching. And so to sort of address this continued deforestation, a pilot restoration program was started in 2008, where grazing was stopped in some pastures, which were then allowed to regrow naturally. So by the time of our study, the oldest pastures were about a decade old. And these pastures are situated within community forest concessions that include towns and agricultural areas, and human set fires are common during the dry season. So a subset of these reclaimed pastures has been successfully protected from burning throughout the decades since restoration began, while other pastures have burned repeatedly over that decade. So to answer these questions, we conducted full community point counts from February through August 2019 in regenerating pastures and nearby mature forest. So we surveyed 37 burned and 60 unburned sites in regenerating pastures, as well as 115 sites in reference mature forest. And in the site map on the right, black points are mature forest sites, gray points are unburned pasture sites, and white points are burned pasture sites. And then we used single season occupancy models to compare occupancy for forest bird species between burned and unburned pasture habitat. And like I said, we focused on forest-dependent species. So we only looked at species classified throughout their global range as having medium or high dependence on mature forest. But based on our field observations, it seemed like species in these global categories actually had a wide range of local dependence on or preference for mature forest. And so we also calculated a local metric of mature forest dependence, which was the relative use of mature forest versus advanced regenerating pastures. And then we asked whether species locally measured dependence on mature forest explained variation in how species responded to burning of pastures. So this might be a little confusing, but we analyzed species that were globally classified as forest dependent. And then within that subset, we came up with a local metric of forest dependence based on data from our sites. So what did we find? First of all, we found that these decade-old naturally regenerating pastures already support a high number of forest bird species. So 63 forest-dependent species had high enough numbers in regenerating pastures to model, and these included 18 species of high conservation concern. But the forest species that used pastures were a subset of the local forest bird community. So there were 23 additional species that were quite common in mature forest, but rare or even absent from regenerating pastures. So overall, these young restored pastures supported a lot of forest birds, but they were still a more disturbance-tolerant subset of the full forest bird community. And we found that burning reduced or eliminated use of regenerating pastures for 58% of the forest species that used pastures. And this result is shown in the graph here, where species are listed on the y-axis in order of their response to burning. So from most negative at the bottom to positive at the top. So the x-axis here shows the beta coefficient of burning on occupancy, and species that fall to the right of that vertical line had higher occupancy in burned pasture than unburned, whereas species to the left had reduced occupancy in burned pasture relative to unburned. So while you can see that a few species responded positively to burning, most responded negatively, and there were actually 2 additional species not shown here that used unburned pastures but were never found in burned pastures. And then we also found that those broad global categorizations of forest dependence do not capture variation in local forest dependence and are insufficient to predict how species respond to fire. So here you can see all of the forest bird species included in our analysis, ordered by their locally measured dependence on mature forest. So species to the right of the vertical line used mature forest more than advanced restored pastures, while species to the left of the line, although they're classified as forest dependent, actually used restored pastures at higher rates than mature forest. And so we asked whether this local metric of forest dependence explained variation among globally classified forest species in their responses to burning of restored pastures. And we found that it did. So a species' response to burning was significantly correlated with their locally measured degree of forest dependence. So the x-axis here is the locally measured degree of forest dependence, with less forest dependent on the left, more forest dependent on the right. And then the y-axis is species' response to burning of pastures, with more negative response at the bottom and more positive response to burning at the top. And so species with the strongest local forest dependence tended to have stronger negative responses to burning, whereas species with lower dependence on mature forest tended to have less negative, neutral, or even positive responses to burning. And this is super interesting because it means that although the forest birds that used regenerating pastures were a more disturbance-tolerant subset of the full forest bird community, the effect of burning on birds in regenerating pastures mirrored the effect of burning that we've seen in mature forest. So in both mature forest and in these restored pastures, the most highly forest-dependent species were the ones most negatively impacted by burning. So overall, we found that naturally regenerating pastures in the Maya Biosphere Reserve have accrued value as habitat for a surprising number of forest bird species during the first decade of regrowth, which is pretty quickly. But at the same time, we show that repeated burning throughout that decade has reduced the habitat value of regenerating pastures for many forest species and even excluded some species from using restored pastures at all. And finally, burning had the worst effect on the most highly forest-dependent species, which are the species most in need of forest restoration. So if you take one point away from this talk, it's that fire prevention needs to be at the forefront of restoration projects in the tropics, because the recent increase in fire within wet tropical forests is really going to compromise the ability of restored lands to support the kinds of species that are most threatened by deforestation. And with that, I would like to thank my advisor, Dr. Amanda Rodewald, my committee members, the Wildlife Conservation Society Guatemala, and my other Guatemalan collaborators, as well as my incredible field techs who were a huge support and without whom this project would not have been possible. And I'd also like to thank my funders. And with that, I will take any questions.